In this illustration, we'll find the different functional groups, degree of unsaturation, hybridization of elements, degree of carbon atoms, chiral centers, heteroatoms, sigma and pi bonds, molecular formula, molecular weight, and percentage of each element in the given compound. This is the first compound, and let us find out the different properties. Firstly, we'll find out the different functional groups in the molecule. Clearly, in this molecule, we can observe two functional groups. They are these ester, and this is an ether group, especially alkyl aryl ether. So there is one ester and one ether functional group. Benzene can also be considered as a functional group. I can keep it as an optional here also as benzene. These are the three different functional groups, or two specifically. The more important are these two. Benzene may or may not be considered as the functional group generally, but ester and ether are for sure the functional groups in this molecule. Secondly, we'll find out the degree of unsaturation of the molecule. We clearly know to find the degree of unsaturation from a structure, we know the rule that one pi bond, carbon pi bond, consists of 1 du, and one ring also contributes to 1 du. There's a simple basic formula. So on applying this to here, we can see there is one carbon double bond O, therefore this will contribute to 1 du. There are 3 pi bonds here, the 3 du, and total pi bonds in this molecule also we had just find out. Pi bonds are total. There are 1, 2, 3, 4 pi bonds are present in this entire molecule, and the number of rings present in this molecule are 1, 2. Therefore, the degree of unsaturation becomes 4 plus 2, that is 6. We have found the degree of unsaturation. Now, let us find out the number of carbon atoms in this molecule. So, on careful counting in this molecule, we find out that the number of carbon atoms in this molecule is 13. Therefore, we can easily find out the molecular formula of this compound. By observing, we can find out the number of carbon atoms to be 31. Let the hydrogen remain as it is. We can use it directly by the theorem of degree of unsaturation to find the number of hydrogen atoms, and we'll count the number of oxygen atoms. So oxygen atoms are clearly 3. Now we know that oxygen do not contribute to the degree of unsaturation of the compound, and the du of the molecule is 6. Therefore, this molecule is 12 H atoms less than the open chain alkane containing 31 carbons. We know for 31 carbons, the number of hydrogen required is 2 into 31 plus 2, that is 62 plus 2, that's 64. Therefore, this molecule must contain 12 less carbons, 6 times 2, less carbons, less hydrogens than 64. Therefore, it must contain 64 minus 12, that is 52 carbon atoms, and this is the molecular formula of this compound. From this, we can easily find out the molecular weight, which can be written as 31 times 12 plus 52 times 1 plus 16 times 3, which on solving will get 472. And on further calculation, we can also find the percentage of individual elements, that the percentage of carbon, we can easily write it down as 31 times 12 upon 472 times 100, which will give the value to be as 78.81%, which can be approximated as 79%. Similarly, the percentages of hydrogens can be found out, that's 52 times 1 upon 472 into 100. That comes out to be 11.01%, which can be approximated at 11%. And finally, oxygen, it is 16 times 3 upon 472 times 100, and making it as 10.01%, approximately 10%. Now let us comment upon the next questions. Finding the hybridization of elements. Let us find out the hybridization of these elements. Very clearly we can see, starting from the left, the leftmost carbon atom is a 1 degree carbon and has the hybridization sp3 because there is no lone pair present or any pi bond present. It is a sp3 carbon. This carbon is for sure, it is a 2 degree, no sorry, it's again a 1 degree carbon because it attached to 1 degree, only one carbon atom, and this is an sp2 hybridized carbon atom because it contains one pi bond. Talking about this oxygen contains two lone pairs, one sigma bond, making the hybridization to be equal to sp2. Talking about this oxygen, we can see that there are two lone pairs in the molecule, but one of them is participating in resonance. Therefore, only one lone pair will be considered. Therefore, there are two sigma bonds and one lone pair, making the hybridization of this oxygen to be sp2. Then talking about this carbon atom is connected to two carbon atoms, making it a 2 degree carbon atom, and that's an sp2 carbon atom since it contains 3 sigma bonds. Therefore, finally we can say this is again also a sp2 carbon atom, but it is 3 degree. This is again a sp2 carbon atom, and this is also a 3 degree carbon atom. This is also an sp2, but this is a 2 degree carbon atom. This is 1, 2 and 3 degree carbon atom, and this is also an sp2 hybridized 3 degree. And talking about this is also an sp2 hybridized 3 degree. This is a 1 degree sp3 hybridized. This is also 1 degree sp3 hybridized. Talking about the next molecules, here it is, we have carbon, 2 hydrogen, that's an sp3 hybridized 2 degree molecule. This is again sp3, and this is 2 degree. This carbon is a 3 degree molecule, sp3 hybridized. This oxygen atom, the two lone pairs, one of them is participating in resonance with the benzene ring. Therefore, this is an sp2 considered because there is 2 sigma and 1 lone pair. Similarly, this carbon atom is 1 degree, it's sp3. This is again an sp3, 2 degree. This is also an again sp3, 2 degree. This is also an sp3, 2 degree. This is also an sp3, 3 degree. This is an sp3, 1 degree. This is an sp3, 2 degree. This is an sp3, 2 degree. This is an sp3, 2 degree. This is an sp3, 3 degree. This is sp3, 1 degree. This is sp3, 2 degree. This is sp3, 2 degree. This is sp3, 2 degree. This is sp3, 3 degree. This is an sp3, 1 degree. This is also an sp3, 1 degree. That is the total hybridization of every individual atom. Now you can clearly count the number of sp3 carbon atoms, sp2 carbon atoms, and sp2 oxygen atoms. And we had also found the degree of carbon atoms. There are no quaternary carbon atoms. There are only tertiary and secondary and primary carbon atoms present here. We have found out the functional groups, degree of unsaturation, hybridization of elements, degree. We need to find the chiral centers. For the chiral centers, we can use the simple technique of sp3 carbons, or the chiral centers it is asking, not specifically carbon, but we very clearly know oxygen does not produce chirality. It does not become a chiral center in general cases. And talking about the carbon atoms, we need to look for an sp3 carbon atom which is attached to 3 different groups. So clearly from the molecule we can see that one chiral center is this, since it is attached to 4 different groups and it is sp3. Secondly, we can see this is also an sp3 and it is attached to 3 different groups, one being hydrogen. And similarly, this is also an chiral center, so we can circle these, and these 3 are the chiral centers, and this here it is 2 same groups. Therefore, this is not an chiral center. So there are 3 chiral centers, so I can just write it down, the number of chiral centers. They are 3. And next it is asking about heteroatoms. Heteroatoms are the different types of atoms except carbon and hydrogen present in the molecule. So only oxygen is present, so there is 3 heteroatoms, 3 oxygen atoms. Now the last part is sigma and pi bonds. So we have already calculated the number of pi bonds to be 4, and for sigma bond you can write the expanded formula of this compound showing every hydrogen counting the individual sigma bonds, or you can use a simple technique that we just need to count the carbon sigma bonds, because every hydrogen present here will contribute to one sigma bond. So let us count the total number of sigma bonds produced due to carbons. So let us just calculate it, and then we'll add 52 to it very clearly. Let us just calculate the number of sigma bonds due to this carbon, and we'll find out that it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, and 35. So carbon sigma bonds, they are total of carbon oxygen is also included, so there's total of 35, and on adding the number of hydrogens we'll get the value to be 87. Therefore there are total 4 pi bonds and 87 sigma bonds, and we have calculated every part of this problem.